react with others. And there was one question, draw the structures of all the oxy acids of chlorine. This was given in some previous paper. Draw the structures of all the oxy acids of chlorine. For this, you should first know how many oxy acids you have in all. You know about HClO, hypochlorous acid, HClO2, chlorous acid, HClO3, chloric acid, HClO4, perchloric acid. We know this is called ic acid, and this is us being one oxygen less, and this is hypo-us. We discussed the names of oxy acids at length, starting with an ic acid, ic, us, hypo-us, and this is perchloric acid, by far the strongest acid, perchloric acid. How will you draw the structures? We had a very simple procedure. We discussed it in some previous question. How do you draw the structure? Very simple. 1 chlorine, 1 OH. 1 chlorine, 1 OH. How do you know 1 OH? The number of OH groups is equal to the number of hydrogens present. Once again, HClO2. 1 chlorine, 1 OH. What happens to the other oxygen? Double bond O. HClO3. 1 chlorine, 1 OH, and there are 2 more oxygens. There are 2 more oxygens, and what is the role of oxygen? It forms 2 bonds. What about perchloric acid? 1 chlorine, 1 OH, 3 oxygens, 2 bonds each. So, this is how you draw the structures of all the oxy acids of chlorine. Repeat, only oxy acids of chlorine. So, there was one other question. How does water react with the following? How does water react with P4O6, P4O10, quite interestingly, PCl3 and PCl5? How do they react with water was the question in the previous exam. You have to think about this. What is this P4O6? Phosphorus trioxide, which you might have liked to write it as P2O3. But in fact, that doesn't exist as P2O3. Phosphorus trioxide doesn't exist as P2O3. It exists as P4O6. Therefore, P4O6, P4O10, PCl3, PCl5, how do they react with water? This is an oxide of phosphorus in +3 oxidation state, +3. So, you get an oxy acid whenever you have a non-metal oxide reacting with water, you get the corresponding oxy acid. Because non-metal oxides, you know, they are acidic oxides. SO2 gives H2SO3, SO3 gives H2SO4. So, non-metal oxide plus water, you get acid. So, P4O6 plus water, you will be getting H3PO3. How do I know it is H3PO3? Because it is a +3 oxidation state. It is a trioxide. So, how can you write the balanced equation? For that, you may have to take large number of water molecules depending on the need. P4O6 plus H2O, H3PO3. Since you have 4 phosphorus here, you take 4 H3PO3, and for getting 4 H3PO3, you need 12 oxygens, 12 hydrogens, you write 6 here. So, is it still balanced? I don't think it is balanced yet. 6 oxygens plus 6 oxygens. So, forget the balanced equation. P4O6 gives H3PO3, and P4O10 oxide in +5 oxidation state, you get H2O plus, in fact, H3PO4 phosphoric acid, ic acid. You got us acid here. Then how does PCl3 react with water? Break the bond, 3H3OH. We have discussed hydrolysis also. POH thrice, phosphorus acid and 3HCl. We have discussed this earlier. And how does PCl5 react with the water? Reaction of PCl5 with water. Break the bond, 5H, 5OH. You get POH 5 times. It may be called H5PO5 and 5HCl. Here phosphorus has a little too many OH groups. You have 5 OH groups and phosphorus cannot retain 5 OH groups with it. So one water molecule is automatically lost. You get H3PO4, phosphoric acid, ick. So PCl3 gives phosphorus acid, PCl5 gives phosphoric acid. So reactions of water happen to be very important. We saw the reactions of water with halogens, reactions of water with oxides, all those things.
Dear students, ఈనాటి ఎపిసోడ్లో గ్రూప్స్ 7th A టాపిక్ గురించి తెలుసుకున్నాం కదా. రేపటి ఎపిసోడ్లో మరో ఇంట్రెస్టింగ్ చాప్టర్తో మళ్ళీ కలుద్దాం. టిల్ దెన్ కీప్ వాచింగ్ KAB టెలివిజన్, ఏపీస్ ఫస్ట్ ఎడ్యుకేషన్ ఛానల్.